Hello, in this video we're looking at MEI FP2, the January 2010 paper question 4, which is on hyperbolic functions. Read the whole question through first. In part 1 we're asked to prove using exponential functions. So no choice of method, and we must show clear and precise working in order to gain all of the marks. We've then got a straightforward instruction to differentiate this result, and it says to obtain a formula for sinh 2x, so hopefully that will just fall out. For part 2 we're asked to solve this equation, and if you compare with part 1 you can see that the result in part 1 is going to be useful to us. It says express your answers in exact logarithmic form, so we won't need a calculator. For part 3 we are given a value for cosh t, and it says show by using exponential functions. So again we've got a given method and it's a show that question, so we need to show all our working. And then for the integral we're asked to find the exact value. Okay, for part 1 we've got to prove that result, and usually with these proofs it's best to start with the more complicated looking side, which in this case is the right hand side. So 1 plus 2 sinh squared x. It says use exponential functions, so let's do that. Replace sinh with e to the x minus e to the minus x all over 2 squared. Squaring that expression, we get e to the 2x minus 2 plus e to the minus 2x all over 4, and that's the same as 1 plus e to the 2x plus e to the minus 2x over 2. That was 2 of those over 4, and then we'll take the minus 2 out separately. Minus 2 times 2 divided by 4 is minus 1. So that cancels with the 1 at the beginning, and we end up with e to the 2x plus e to the minus 2x all over 2, which of course is cosh of 2x. It then says differentiate this result to obtain a formula for sinh 2x. So we've got our result cosh 2x equals 1 plus 2 sinh squared x. Differentiating both sides, so differentiating cosh 2x using the chain rule gives me 2 sinh 2x. And differentiating the other side, differentiate 1 we get nothing. Differentiate 2 sinh squared, that's 4 sinh. And then differentiate sinh to get cosh. Dividing both sides by 2 gives us sinh 2x equals 2 sinh x cosh x, which is an expression for sinh 2x as required. For part 2 we're going to use the result from part 1 and replace that cosh 2x with 1 plus 2 sinh squared x. So, starting with the equation as given, 2 cosh 2x plus 3 sinh x equals 3. So that's 2 times 1 plus 2 sinh squared x plus 3 sinh x equals 3. And I've now got a quadratic equation in sinh x. So I'll just tidy that up. I've got 4 sinh squared x plus 3 sinh x plus 2, and then if I subtract 3 from both sides that will give me minus 1 equals 0. I can factorise that to get 4 sinh x minus 1 multiplied by sinh x plus 1 equals 0. If you find that difficult, then just rewrite it. I'll show at the top 4s squared plus 3s minus 1 equals 0. That might make it easier for you to get your head around the factorising. So from that factorisation, I get that either sinh x equals a quarter or sinh x equals minus 1. And therefore that x is r sinh a quarter or x is r sinh minus 1. Now in the formula book we have that r sinh of x is equal to the natural log of x plus root x squared plus 1. So substituting that in, I get natural log of 1 quarter plus root 1/16 plus 1. That's natural log of 1 quarter plus root 17 over 16, which is natural log of 1 plus root 17 all over 4. And the other expression, natural log of minus 1 plus 1 plus 1. That's natural log of root 2 minus 1. For part 3, we're given that result, so let's start by writing it down. Cosh t is equal to 5 over 4. It says use exponential functions, so we'll just use the definition of cosh, e to the t plus e to the minus t over 2 is equal to 5 over 4. So multiplying through by 4, 2e to the t plus 2e to the minus t is equal to 5. Then if we multiply through by e to the t, we get 2e to the 2t plus 2 equals 5e to the t. That's a standard method for getting ourselves a quadratic equation. So multiplying through by e to the t. Rearrange that to form a quadratic equation we can solve. And if you struggle with these, you can write that as 2e squared minus 5e plus 2 equals 0 and factorise that. But we get 2e to the t minus 1 e to the t minus 2 equals 0, from which we get e to the t equals a half or e to the t equals 2, and therefore t is log a half or t equals log 2, and of course log a half is minus log t, so we end up with t being plus or minus log 2, which was the answer we were supposed to get. Finally, we're asked to find the exact value of this integral. So if we look in the formula book, we find that there's a formula for the integral of 1 over root x squared minus a squared, and it's r cosh x over a, which is log of x plus root x squared minus a squared. So we're going to use a equals 4 in here, and we can simply write down straight away that that's equal to the log of x plus root x squared minus 4 squared, which is 16, evaluated between 4 and 5. You're not expected to do any more working than that. The formula's in the formula book. It's not a show that question, it's simply find the value of the integral. So now we plug in the values. Natural log of 5 plus root 25 minus 16. Take away log of 4 plus 0. So that's log of 25 minus 16 is 9, square root of that is 3, plus 5 is 8, minus log of 4. Using the laws of logs, that's log 8 over 4, which is log of 2. Okay, let's see how the mark scheme works for this question. For part 1, there is a single mark for knowing that e to the x minus e to the minus x all squared is equal to that expression there. There's then another mark for the correct completion. For the differentiation, there is a single mark for getting both correct derivatives and a single mark for the correct completion. For part 2, there is a method mark for making use of part 1 and putting in this substitution. There's an accuracy mark for ending up with the correct quadratic. There's then a method mark for solving the quadratic and an accuracy mark for doing so correctly. There's a method mark for making use of this formula to obtain at least one value, correct or otherwise, and accuracy marks for each of the two solutions, and you are required to evaluate x squared plus 1, the square root of, in both cases. For part 3, there is a method mark for ending up with a quadratic in e to the t. There's another method mark for solving it, an accuracy mark for doing that correctly, and an accuracy mark for completing to the answer given with a convincing set of working. There are not many marks for the integral because it's mostly just copying from the formula book. There is a single mark for copying that formula correctly from the formula book using a equals 4. There's a method mark for substituting in the limits and an accuracy mark for getting down to the correct final answer. If you want to find videos of other questions on this unit or on other units, please visit the Further Mathematics Support Programme's website. Goodbye.